Hello everyone, I'm Saket Bansal, and today I'm talking about weighted shortest job first in Scaled Agile Framework. In many time in development, we deals with limited capacity, and the backlog is far higher than the capacity. And in order to make maximum economic benefit, we need to figure out a way of prioritizing these jobs in a way so that we make maximum use of our available capacity. The weighted shortest job first, the WSJF, is a prioritization model which helps us in sequencing the job in case of, say, if they are features, capabilities, or epics to achieve maximum economic benefit. In case of SAFe, the WSJF is estimated by estimating cost of delay and dividing that estimated cost of delay by the job size, an estimated job size. We'll talk about the SAFe way of looking at cost of delay in a while, and as well as the WSJF in a while. First, let's understand these things in a generic term. Cost of delay. What I am going to lose by delaying something by a day or by a month. So the economic benefit which I lose by delaying something is a cost of delay. You might heard of a quote, time is money. So the time which I am delaying, I'm paying something for it. When I have, say, 2 features and I can only finish one in that particular day, and both of these features cost me something, but if I delay them to the next day. So I need to understand the cost of delay of a feature 1 and the cost of delay of a feature 2. And I need to pick up the feature in such a way so that I make maximum economic benefit. If the size of both the features are same, I can definitely pick up the feature where cost of delay is higher so that I pay less on overall cost of delay. So when the job size are same, it's easy because we can just estimate the cost of delay and prioritization based on that. But what if the job size are different? Now let's take an example of 3 jobs where job sizes are different, and we will observe how using WSJF can help us in maximizing economic benefit by way of minimizing overall cost of delay. So here I have 3 jobs, A, B, and C. The cost of delay of A is $10 per day. So not doing A costs me $10 per day. And doing the job A, it will take 5 days of time. And once these 5 days are over, I push this job in the market and I start getting $10 because delaying each day is costing me $10 per day. Assuming that somebody is ready to pay for this particular job, and every day I could make $10 per day once it goes into the production. And if I do it first, then after 5 days, I start earning $10 per day. Now, the cost of delay of a B is 5, but it just takes 1 day to finish. And the cost of delay of C is 1, so $1 per day, and it takes 5 days to do this particular job. So I can say at this particular moment, I am starting my day 1 morning. Today, at least I have a cost of delay of $16 because none of these 3 things are done. So in the morning, this is something which is standing on my head, and I need to figure it out. How do I prioritize? So this is something, a first thing in my priority. Now, if I see this clearly, whichever way I prioritize, in the beginning of the day, I anyway have a cost of delay overall of $16. A is losing $10 because it's not done, B is losing $5 because it's not done, and C is losing $1 because it is also not done. So if I sequence in a one particular way, and then we observe what is an overall cost of delay. So when I see this, let's sequence it by using A, B, and C. So I'm just saying, let's do the A first, and then do the B first, and then do the C first. And let's understand how the overall cost comes to when I use this particular sequence. Here I would like to explain, since the A will take 5 days, so you can say nothing has gone into production. For 5 days, A is in process. So this is, you can say that A job is in progress, and per day, anyway, I am costing $16. So this is something like all the three jobs are not in production, and this is something is happening for initial 5 days. But on the 6th day, the 5th day night, I push into the production. From a 6th day onwards, I don't have to pay this one. So I come down. Yeah? So because the $10 earning gets started, so that's cost of delay is over. And now I'm working on the $5 thing. $5 thing just took a 1 day. The day 6, the $5 is over. And from day 7 onwards, I am just occurring a cost of delay of $1 because the other two jobs are already giving me benefits. Yeah. So this is how we can probably see this, that okay, I'm doing job A, I'm doing job B, and I'm doing job C, and this is how I calculate overall cost of delay. Now, if I see this thing in further and I calculate the exact cost of delays, it will come to that $16 per day cost of delay multiplied by number of days, it comes to $80 because it was not there in production. So initial 5 days, I end up losing $80. The next day, the 6th day, I done with the $10 thing. So I am no more losing $16. I'm just losing $6 because the 10th one is over. So 1 day I lost $6 and it becomes a $6 overall cost of delay. On the last 5 days, I was losing just $1. So my overall 5-day cost of delay was 5. So if I sum all these three together for all these three particular jobs, my cost of delay in this particular sequence is coming 91. So the idea here is that the way I prioritized, I'm not saying it's a right prioritization or wrong prioritization, the way I prioritized, and I just had 3 things to do and I had 11 days to work on it overall. And that because each thing was taking a particular number of days, and I am the one guy who can do it. I can't do it in a parallel because that's a limited capacity. And if I just change the sequence, I might incur a different cost of delay. But as of now, I have $91 as a cost of delay. Now let's see a different situation where I apply the WSJF formula. Now, what is WSJF and how do I apply that particular formula? So the WSJF formula is pretty simple. I say cost of delay divided by duration. I'm saying this is a generic WSJF formula, the SAFe WSJF formula we will see. So when I apply this, I divide the cost of delay of 10 by duration 5, and I get cost WSJF of 2. You can see it here. And when I, so this is 2 because 10 divided by 5. For jobs B, it's 5 divided by 1, it's a 5. And for job C, it's a 1 divided by 5, which is 0.2. So if I see the WSJF, I clearly know that the B job should be done first. And if I do this, I should have less overall cost of delay and I should get more economic benefit. That's what the formula tells us. Now let's validate that, because the way we plotted that 11 days graph, let's plot the same graph again and see what happens when we sequence it B, A, and C in this particular pattern. So I am going to the second plot, and here you can see on day 1, nothing is finished. Morning of the day 1, anyway, you pay $16. You have a $10 going for a job A, $5 is going for a job B, and $1 is going for job C. So you can see that $16 is more or less day 1 is as it is. But day 2, you know, the $5 job starts giving you money. So you are no more delaying that job. That thing started earning money for you. So your cost of delay came down on the day 2 itself, and it became 11. Yeah. So now you are doing job B. This is job you are doing, but it will take 5 days to finish. So this 11 will continue for 5 days because this is how you are prioritizing. So if I'm saying 11 multiplied by 5 for the day 6 to day, so day 2 to day 6, I am incurring $55 as a cost of delay in total. Now, once that is done, say day 6, the job B is done, and we are only left with job C. In that particular case, it's easy because it's just a $5 and 5 days, and we are paying $1 per day. So if I do this particular way, you can see my overall cost of delay by using this particular sequence is 76. So by applying the WSJF formula, I have reduced the overall economic impact, or I have of delaying jobs because of doing a prioritization by calculating cost of delay divided by duration. So in a similar way, we can just do a quick mapping of both the things. So you can see both the graphs hand in hand. When we were doing without WSJF ABC, you can see that overall area of this graph clearly represents that, yeah, we end up paying $91, and now we are paying $76 when we are doing with the WSJF. It is also pretty much clear what happened here is that if you just interpret this, by doing job A first, what we did is that we paid for job B for 5 days. And the job B was costing us $5 per day. So we end up paying $25, which we were not doing in the case of the second case when we had a COD of 76. So we had a $25 difference, but we could finish the $10 job one day before in the 91 COD, and that's why the 25 minus 10 give us overall difference of $15. So the difference between these two calculation is $15, and which can pretty much by observation you can also see it might be happening because of the change in the sequence of job A and B. And this is the idea of WSJF, which helps us in prioritizing based on the economic benefits. Now, let's look into the way SAFe calculates WSJF. The problem is it's not that easy to estimate cost of delay, and many times it requires good amount of data collection. When we are looking at this particular problem in SAFe, we come up with a relatively faster model which helps us in identifying relative cost of delay. And the Scaled Agile Framework gives us a model which helps us looking into 3 dimensions and estimate a relative number when we have multiple jobs in preview and help us in calculating overall cost of delay. And when it comes to the duration, it's again difficult to estimate duration, but it's easier to estimate relative size of the jobs, because when we have say 5 jobs in preview, I can easily find out which one is the smallest one and which one is the largest one. So rather than using duration, I can use job size as a denominator. So in case of SAFe, the WSJF formula gets converted into cost of delay divided by job size. And the cost of delay is further looked into 3 dimensions: business value, time criticality, risk reduction, and opportunity enablement. And these 3 dimensions helps us in finding out cost of delay. Let's look into all these 3 dimensions one by one, and then we do a small sample case to understand this concept further. Business value. What is a lifetime business value of a particular feature? What kind of a revenue we are going to get by doing something? That's the primary understanding of business value. Time criticality. How business value get achieved over a period of time? You can see here job A and job B. The job A might have a higher business value, but it declines in its business value over a period of time, but it declines with a I would say less. The steep curve, the slope is less, whereas the job B, which you see in this curve, its business value declines drastically after a given point in time. So you can see the job B is time critical because its estimated business value will evaporate if we don't deliver it in a given amount of time. So when we are looking at various features and I'm looking at a time criticality direction, what I'm seeing is how business value is declining over time. Yeah. So things like Christmas features. So if you do this feature by Christmas, you make money. If you don't, you don't. Yeah. So it's like a time critical feature. Sometimes you are chasing a particular milestone. You either do by that milestone or you lose achieving that particular opportunity to learn or to demonstrate or to earn money out of that particular feature. So those particular features may go higher in a time criticality. Risk reduction and opportunity enablement. And I find this is the one of the dimension which is quite confusing for many professionals. Now, when I have a multiple features in place and I'm looking at them in order to prioritize, do I have a feature which helps me in reducing the risk exposure, which helps by doing that particular feature in early stage, I can mitigate many things which can happen in the later stage. So if I have that feature will go up in risk reduction and dimension. And the opportunity enablement dimension can also play a role where I may have a positive risk. So if doing a particular feature increases my opportunity of achieving something in future, that is something also goes into higher space. Let me explain. So something which I do now, say I want to experiment particular customer behavior, and I want to add that particular feature, but this particular feature will not have a business value in future, but it helps me in learning something which can enable me to achieve something with the help of a different feature. So it enables the opportunity. So if you have those kind of features, they may also go high in opportunity enablement and risk reduction dimension. So how it works, let's see in the form of table, and that will be easier way to explore and understand this particular thing. So I have prepared a table where you can see feature, you have a flexible search, user profile, checkout, and then we have a column, business value, time criticality, risk reduction, and opportunity enablement. The cost of delay will be a sum total of business value, time criticality, risk reduction, and opportunity enablement. And job size is also estimated relatively for these three jobs. Assuming in Scaled Agile Framework, we have to do a cost of delay estimation for these three features. So how should we go about it? So what I have to focus on is I need to see a one column at a time. So I need to see this particular column at a time, that, okay, I'm looking at business value, assuming. Yeah. So when I'm looking at a business value, I will use a scale of Fibonacci series till 20, modified Fibonacci series like 1, 2, 3, 5, 8, 13, 20. I just stop there. So if I use those rank number, out of these three, which one is giving me the least business value? So assuming in this particular case, I may say that, okay, here what I feel is that I'm getting least business value here. So I may give it 1. So I start with putting the 1 there. Yeah. So that's, I'm looking at a business value. Again, what is a business value? It's an estimated lifetime business impact of that particular feature. Now, after doing this, I need to find out what is the next. So I may see the checkout gives me the maximum business value and flexible search is somewhere in between. So I may end up estimating, say that, okay, this one is 3 and this one is 5. Now, the question arises, who are these people and who is doing this estimation? Is it one guy or a group of people? So the way we look at the planning poker estimation where development team size the work, this is also a similar approach where business owners and product management people in SAFe, they come together. Yeah, they may invite some experts also who has an insight around business value, and they are discussing in the form of wideband Delphi or some other way to come up to these numbers so they have an agreement on business value. And I see that's the biggest value of doing this activity. In the absence of that, different stakeholders may keep thinking in a different way. So it's a facilitated event where business owners and product owners and product management come together, and they are the one who are estimating it. So once we are done with the business value, we move to a time criticality stage. So is there anything which we need to do now, or else the overall business value of that particular feature will evaporate? So in a way, we can say in this particular case, assuming again it's a relative to the particular way of working in a product, I may say that, okay, none of them is time critical. They more or less follow the similar curve. If that is the case, yeah, I'm just taking a case and I put a 1, 1, 1 across there. Now, risk reduction and opportunity enablement, which one is least impacting you in risk? I would say that checkout, I don't see it helps us in mitigating any risk, assuming. But user profile, it helps us in enabling a lot of opportunities because I can start learning about user in advance. So I say that, okay, this gives me a lot of opportunity enablement. Flexible search, because I have a pure performance criteria is in place, and there is a possibility once I may end up changing my architecture if I don't achieve those flexible the performance criteria. Doing flexible search mitigates the architectural risk which I might occur because of not having the proven search mechanism. So I may say this is little higher, and I would say that okay, this helps me in reducing risk, and I may say it's more or less equivalent to user profile, and I give it 5. Again, this is just a sample number, and what I'm showing here is this will be a context based calculation, but here we are just doing it for the sake of simplicity. Now, what is cost of delay? Now, once I have the numbers given by the stakeholders on business value, time critical, and risk reduction and operational enablement, I can sum them and calculate cost of delay. So in this particular case is 3 plus 1, 4, 4 plus 5, 9. 9 is a cost of delay of a flexible search. And when I see as a user profile, it's 7, 5 plus 1 plus 1. And when I see a checkout, I also see it 7. So this is like cost of delay. Now, job size. Job size is more or less in the same way we do story pointing, but again, it's a relative thing. Yeah, so I need to see out of these 3, which one is the smallest job. I go with, again, it's a system architect supported by some of the selected team members or the people who has some technical knowledge, and the product management plays a role in identifying the job size, and they agree and discuss the various possible things which can go in this particular thing, and based on that they may come up with, okay, this takes 1, this is the easiest one, and then they may say that okay, this one is the second possible one, and this one is again more or less on the same space, but yeah, we give it on a 3. So again, these are estimates. These are estimate based on the people who understand the job size. Now, what is WSJF? So WSJF is cost of delay divided by job size in case of SAFe. So here it is 9 divided by 3. It will comes around 3. Yeah, 7 divided by 1, which is coming to 7 here, and then 7 divided by 3, so which is like 2.3 something, yeah, which will go forward. So this is the WSJF. So if you follow the WSJF prioritization technique, in this particular case, we go with user profile as the first job to be done. Now you also see it's a cost of delay divided by job size, and I gave you a generic example where we saw that our goal is reducing the overall impact of cost of delay. Yeah, so this is how we can use cost of delay in Scaled Agile framework. I do encourage you to check more details related to cost of delay by visiting Scaled Agile website, scaledagileFramework.com, and you can also exploring the training calendar. We do a lot of training around SAFe to understand other part of Scaled Agile and cost of delay also maybe a little more in detail. Thank you for watching.